Okay, this is the rational function graphing. A couple problems I want to go over from the quiz. So let's see, first we have f of x equals 2x plus 4 over x squared minus x minus 6. And we want to graph it and show all asymptotes. And then question 3 below, we'll want the domain, range, and end behavior. So a good idea is to always start by factoring if you can simplify something. So I see that numerator has a common factor of 2, which I can bring out front and be left with x plus 2. And the denominator is a trinomial that can be factored into x minus 3 and x plus 2. Okay, and just stopping at this point kind of lets you see which values are going to be restricted or excluded, from the domain. So for this factor right here, if x were 3, we would have a 0 in the denominator. All right, and then from this factor here, if x were negative 2, we would have a 0 in the denominator. So I know for sure those are the two values that are not in the domain. Right, x cannot be 3 and x cannot be negative 2. Okay, because again, either one of those is going to give us an error because we'll have a divided by 0 in the denominator. So what we look at next is to determine what type they are is there anything that's canceling these factors out? So the x plus 2 does get canceled out. It can get canceled out. So this thing would further simplify to just 2 over x minus 3. Okay, so that means that the negative 2 is actually going to be a hole in the graph. So we'll have to be aware when we graph it. The factor that got us the other one down here, that one still remains, so that's going to be our vertical asymptote. So I'm going to go ahead and draw that in. Do it as a dotted line, because again, it's not really part of the graph, but it's just there to help us get the graph set up. Okay, so that's the vertical asymptote there. All right, and then before we graph it, let's now think about what about a horizontal asymptote. Okay, so for that thought, I'm thinking about what is the degree here. So this is x to the second power. The numerator is just x to the first power. So when you have the denominator being larger, that's going to force, in the long run, think about a fraction. If you have a fraction and it's bigger in the bottom, in the long run, that thing's going to tend to 0. Okay, you're dividing something by bigger and bigger numbers, right? The denominator's bigger. So that means that in the long run, this thing's going to approach 0. That's going to be the end behavior, and it's also going to be our horizontal asymptote at y equals 0. Okay. Now that will be a value that's not in the range. Okay, we're going to approach that asymptote, but we never quite get there. So y cannot be 0. Okay, and there's also going to be a second restriction here that we'll see in a minute coming from where the hole is. So if we graph this thing now, you can kind of just go to your calculators to kind of see what it looks like, but I know for sure that this one curves up and stays within the asymptote, something like that. So we're just kind of approximating where it is. If we wanted to get the y-intercept just to be a little bit more accurate, what I could do is actually put in 0 for all of the x's. Okay, so we can see just looking at the original function. So looking up here, if I put in a 0 for all the x's, the numerator would be 2 times 0 plus 4, so it would really just be 4. So we can find in the y-intercept here. Numerator would be 4, and if the x's in the bottom were 0, that would be over negative 6. And that is actually negative 2/3. So that should be where our y-intercept's going to be. Okay, oops, so that should be a little bit higher, somewhere up there. But then I also know when I get to negative 2 for an x, there's going to be a hole in the graph. So using your calculator, we know it has to kind of stay within the asymptote. We do something like this. There's a hole there, and then it's going to approach that asymptote. Now we need to figure out what is the y value, or what would it have been where the hole is. Okay, so if I look at that graph, if I were to just plug negative 2 in, right, this is x equals negative 2, there's a hole there. And I know if I just plug negative 2 into the original, I'm going to get something undefined. So what you're going to have to do, you're going to have to use the factored version of it. Okay, I can plug negative 2 in this one and see that the y value would be, the denominator would be negative 2 minus 3, so it would be 2 over negative 5. Okay, so that's what the y value would have been there. So that value, negative 2/5, is also not in our range because we never get through that y value. There's a hole when it would have gotten there. Okay, so we kind of use the factored form to figure out that value. And then as far as end behavior, we can see as we go to the far right and to the far left, it actually is exactly what the horizontal asymptote is. Right? In the long run, I'm going to write this as one statement since both ends are the same. So as x goes to positive or negative infinity, in both cases the y is going to 0. So I can write it as a single statement because both ends go to the same place. Okay, number 2, this one is more kind of set up in the like the parent function would be, and we can just kind of use the transformations to help us a little bit. So we can see in the denominator there's a +2 in with the x. We know that anything inside the function is going to be a horizontal shift. Or you can also think of it just like we did before. What would make that 0 basically? When you set it equal to 0, you can see that -2 is the value not in the domain. Okay, that would cause a 0 in the bottom. There's no factor to cancel it, so that's going to be a vertical asymptote. Right at x equals -2. Okay, then let's think about horizontal asymptote. Same thing, we're going to compare the degree. Okay, in this case, the numerator doesn't have any x's at all, so the denominator's degree is larger. Okay, so it's kind of like the opposite case we had over here. In number 1, the denominator was bigger. Actually, this is the same. I'm sorry, I was thinking something else. The denominator is bigger again. So this one would be going to 0, just like number 1 did, but we do have a vertical shift there. So instead of going to 0, the asymptote gets shifted up 2 as well. So the horizontal asymptote is at y equals 2. And then it's just a matter of getting your graph thrown in. And you could find the intercepts if you wanted to be a little bit more accurate. So if we wanted to, for example, find the y-intercept, we would plug in 0 for the x, so it would end up being 3 over 0 plus 2 plus 2, which kind of simplifies that's 3 over 2 plus 2, so it's really like 1.5 plus 2, so it's really about 3.5, so that'd be the y-intercept, just to get a little more accuracy to the graph, and then just kind of tuck it within the asymptotes, curve it, and keep it in there. And the other one, we would be able to find the x-intercept if we wanted to, so we could figure out where the other one's going to cross by setting the y to 0. Okay, so let me get a little more space up here. If we want to know the x-intercept, we're going to set the whole equation, the y value equal to 0. And we would solve that for x. So I would first subtract 2 from both sides. Okay, then you could multiply both sides by the x plus 2. Okay, so when I multiply -2 times x plus 2, I'm going to get -2x minus 4 equals 3. So I distributed the -2 to both of those. And then when we solve that, we would add the 4 to both sides. So -2x would equal 7. And divide by -2. -7/2. Okay, -3.5. So that value is right here. And then again, we know it just kind of stays within the asymptotes as well. Okay, so that's our graph. To finish number 4 down there, the domain was -2. I'm sorry, x could not be -2. The range, due to the horizontal asymptote, we can see the y values will never get to 2. Again, that's the horizontal asymptote. Those always kind of go together. And the end behavior goes with those too. Okay, at both ends, as this thing were to continue out both directions, it's approaching 2. So I would say similar to the last one, as x goes to either way, so positive and negative infinity, the y values go towards 2. Okay, so just try and get some sort of order. I like to do the process in the order I just did it in, where I kind of worry about the domain first, get the asymptote in, see if there's any hole, and then worry about the horizontal asymptote, which would go with the range. And then if you want, you can do the intercepts to get a couple points, and you can just use your calculator to kind of figure out where the curves go. Normally, it seems to be most of the time that they're going to be like in the top right quadrant and the bottom left, like from where the asymptotes divide the graph. Unless there's a negative multiple, then they'll get flipped down. But sometimes it depends if there's an x in the numerator and things like that. So just use your calculator to get those branches as approximate.